Hello friends, welcome to the ninth video of the Java online course. We are now working on object-oriented programming using Java on classes and objects. Okay, so last time we have started with the inheritance and we have seen the properties, applications of inheritance in this. Now we are continuing with the same video, and the properties of inheritance will be now extended more in this particular video also. So let's start with the first concept, method overriding. So it's not to be confused with the concept of method overloading that we have seen in the second video of OOP. Method overloading means same name and different task. So their parameters of the methods are different, and based on the parameter return types, its functionality of the method is different. But overriding refers to some different name. Overriding contains same method name, same parameter, but the methods are declared into different classes. In the class hierarchy, when a method in subclass has the same name, same argument and same return type as the method in superclass, then the method in this subclass is said to be override in the method in the superclass. So overriding the functionality of the method from superclass is possible in the subclass also. When an overridden method is called from within a subclass, it will always refer to the version of the method defined by the subclass. The version of the method defined by the superclass will be hidden. That's why what we call as overriding. Okay, so hiding the superclass method and reusing that particular method by different operations is called as method overriding. Very regularly this particular concept is used in many topics of advanced Java programming. So try to listen and perform these applications very perfectly. So let's go for overriding concept. So let's see. My first program, method overriding. So simple program I just created here. So first class maths I'm created. Okay, so class maths where three variables are declared, var1, var2, var3. Inside it one constructor I am having. It contains two parameters by which I am declaring the var1 and var2, and one method called as calculate. So this calculate method is performing addition of these two numbers. Fine, and printing this addition on the screen in the var3. That's what the first class function is. Now this class I am inheriting into another class whose name is arithmetic. Now class arithmetic extends maths. Okay, so here I am having one constructor with two parameters. So these two parameters I am passing to superclass constructor here. So it will go here, and this var1 and var2 will be initialized by the super keyword. Okay, in this particular system. Now here also I declare the same method, void calculate. See here, void calculate. Okay, void calculate is written there. You can check it. This particular green circle overrides the method from inheritance, and you can check it out. It's showing this one because the same method I am redeclaring here, but its internal parameters are different. So see, this is how I am calling the above class method. I don't want that to get called. So here I am doing addition, and this method is doing subtraction of the variables which you put as input to this arithmetic. Okay, subtraction is printed in var. So that's what the difference is. This method is doing addition of the values, and this method is doing the subtraction of the values. Okay, so when I create the object of this class, then it will call this method, and when I create object of this class, it will call this method. So it's calling this method, not this, because this method is overridden. It is overriding the definition of original class. Okay, that's why its own method preferences are given. But what if I want to call this method here? So I can use the super keyword. The third is of super now. Super.calculate. Okay, this way. So I'll just put it in comment. I'll show that after this program's execution. And now here I'm creating object of this subclass arithmetic. A is equal to new arithmetic 30 and 18. So 30 and 18 will go here, x and y, and from this super it will go here. So var1 and var2 will be initialized to 13 and 18, 30 and 18, and then I'm calling calculate method. So let's see. Calculate is overridden method. That's why preference is always given to its own method only. So own method means it will print only subtraction, because calculate is present here. Its own method will be given the preference subtraction. So 18, 30 minus 18. Okay, so that's what 12 will be printed on the screen like this, subtraction. So its own method is called. Why? Because method is overridden. Same definition is present, only the statements inside the methods are different. That's why operations output that we are getting on the screen, they are different. Okay, so let's see, if I want to call this method, so if I create object of this class, then I can call this calculator, getting. But with this object, if you want to call, then you can make use of the super dot calculate. So super class calculate will be called in this calculate and will get the output on the screen. So if I save this, if I run this, check it out. Oh yes, 48 is the addition of them and subtraction is 12. So in this way we are going to have the method overriding concept. So method overriding will be performed by this particular way. One method, multiple definitions, any such definitions are possible, but this definition should be stored in different classes connected by the hierarchy of inheritance. This is how we can make use of the simple overriding concept. Okay, so it is basically why overriding. Overriding is giving the birth to polymorphism. So basically polymorphism means, so let's talk about the polymorphism. Polymorphism is a fourth most important property of the object oriented programming. One name, many forms. We have already seen one form of polymorphism, and that form of polymorphism is called as compile time polymorphism. With the help of method overloading, we have acquired the compile time polymorphism. It means that when program is compiled, that time compiler knows which form of the methods to call. So because parameters are known, and then we are knowing which particular method will be called as per the parameters. But second way of polymorphism is called as runtime polymorphism. What runtime polymorphism means? Runtime polymorphism calls the respective method when program is in execution. It means that, see, we have seen two steps of execution. First step is called as compilation of program, Java compiler. Second is Java interpreter. So compiler checks for method overloading and interpreter checks for method overriding. So when interpreter is checking, it is called as runtime polymorphism, and when compiler is checking, it is called as compile time polymorphism. So second way is called as runtime polymorphism. How it is achieved? So method overriding concept is extended in Java, by which we are going to make use of the compile time polymorphism here, and this terminology is called as dynamic method dispatch. Method overriding forms the basis for one of the Java's most powerful concepts called as dynamic method dispatch. Now, dynamic method dispatch resolves a call to an overridden method at runtime rather than compile time. Dynamic method dispatch is important because this is the only way in which Java implements the concept of runtime polymorphism. The superclass reference variable can refer to subclass object. Okay, this property now I am going to use here in the method overriding. Java uses this concept to resolve the calls to overridden method at runtime. So two application programs I'll be showing here. First program is simple, second program is the application oriented program, and let's talk about this concept of runtime polymorphism with the help of overriding concept and dynamic method dispatch. The first program is dynamic.java. So let's see this one. So let's see how exactly we'll try to understand the concept of runtime polymorphism first with the help of this simple program. So here I am having the first class called as principal, which contains the message method. This is principal. Okay, that's what it's printed. Second class is professor, which is extended, inherited from the principal class, which also contains the same method, which prints this is a professor. And now in this hierarchy I am creating one more class called as lecturer, which extends the professor and is printing void message as this is lecturer. Okay, so simply three methods, same definition. It means that the method message is overridden. Now how to call these methods at runtime? When the program is compiled, that time compiler cannot distinguish between the statements. So at runtime, compiler decides which version of the method to call. So how to do this one? So let's go. Yes, see the dynamic. Now three objects I am creating here. Okay, principal, then professor, then lecturer. Okay, so three objects x, y, z, and now superclass reference variable principal ref. REF is the reference variable of the topmost superclass. So with the help of that variable can be assigned with any subclass object, as we already seen this. Now ref is equal to x. So this x I am storing object of its own, I am storing in ref, and ref dot message. So its own message will be called. Now I am changing my reference variable. As I shown, subclass object can be assigned to superclass reference variable. So y is a subclass of x or the principal. So I can assign directly y to the reference variable of superclass and call it. So now y, that is professor's message method will be called. Third case, I am assigning z, that is the third class reference variable there, and ref.message. Now in this case, lecturer's message method will be called. Yes, this is what we call as dynamic method dispatch. Assign the object to the reference variable of the topmost superclass and call the things which are common in all. So basically, common thing is the method name. Though the method name is same, we can call their respective version by this particular concepts, which we refer as dynamic method dispatch. Now, why it is called as runtime polymorphism? Now look at these three statements: message, message, message. Now, when compiler runs this program, compiler may think that output of this statement, and this statement is same. Why? Because parameters, object and method are same. So output can be same, but compilers, this is misconception of compiler. So at runtime, when compiler is in if program is in execution, that time it will be identified what object currently containing. So first of all, ref contains object of x, then ref contains object of y, then ref contain object of z. Okay, and based on that, the different versions of message will be called. Okay, that's why it is called as runtime polymorphism. So by dynamic method dispatch, we are achieving these particular concepts in Java. When I run this code, check this. First of all, ref.message printing principal, second time it's printing professor, third time it is printing lecturer. Okay, so this is how dynamic method dispatch can be used. Superclass reference variable can store any subclass object. Okay, so runtime polymorphism is achieved by this particular concept. You can try this code, and now we'll go to some application oriented program for this particular concept by using the dynamic method dispatch. So let's go for that. Check it out. A very big program is there. I'll just summarize it quickly, what exactly we are going to do in this program. So I'm having a class called a square. Okay, inside it we have side and val. Two things are mentioned. Side of the square, I'm reading from the user, and it's initializing here in constructor, and it contains a method called as area, which prints the area of the square. Okay, side is printed, area is printed. Area means side square, side into side will be the area of that particular square. In second case, rectangle, which extend the square. So now when I'm extending it, all these things are available here. Now rectangle contains length and width. Okay, so this I'm initializing in the constructor, and then again same method I'm writing here, void area. No parameters changes, no return type changes, no name changes, but the function is doing the finding the area of the rectangle, which is equal to length into width. Okay, this will be the area of the rectangle. I'm printing the length of the rectangle, width of the rectangle, and area of the rectangle over here by using the same method. Okay, if you click on that, you can check this method and this method. Okay, now a rectangle is inherited in circle. Circle extends square. Sorry, it's not extended here. It is extended in hierarchical fashion. This is what we are having, hierarchical inheritance. Square is superclass and it contains two subclasses, rectangle and the circle. So in both the cases, concepts are common. So here circle is having rad, that is the variable which will store the radius of the circle. Okay, so circle radius will be initialized by using this constructor, and again same method I am using here, that is void area. So this method is now finding the area of the circle, So how do I find the area of the circle? So let's have that. Value is equal to float of math.py. So this is default constant that math class in Java containing is pi, math.py into rad means radius square into pi will be the area of the circle now. Okay, so this I'm printing here, radius is printing and area of circle is printing. So very large hierarchy I'm having by using hierarchical inheritance is created here. Square, then square contain rectangle and the circle, two subclasses present over here. Okay, so let's go to check the output. So what I have done here, see, I'm finding the square of area of the square whose side is 18. Here I am finding area of the rectangle whose length and width are 5 and 26, and area of the circle whose radius is 14.20 float. Okay, and now I am creating the reference variable of the superclass, that is square is the reference variable of the superclass. And now first of all I am assigning s into it. So first of all I am finding the square and ref.area. So it can currently contain the object of square. So it will call this method from the square class. Okay, then I am printing object of the rectangle. the second object here. So it will find the area of rectangle. Now from rectangles class I'll be calling the area method here, and in third case, that's I'm putting C, that is object of the circle, into it, and once the object I am putting into reference variable, then ref dot area is calling the area of the circle. Yes, so this is how we are going to make use of the concept of the runtime polymorphism with the help of dynamic method dispatch. The practical application, you can see this, how they are connected together and how this method will be called when I run this particular program. Check it out. So first of all, the square is called, fine, s dot area, then again s dot area, ref dot area, and again ref dot area. Their outputs are different, so different versions of the methods are called here, though the statements are same, but the object present inside the reference variable is different. That defines which version of the method to call here. So this is what we call as polymorphism or the dynamic method dispatch concepts. Very big program. The program is given along with this particular video. You can try this, you can modify that and try to understand the concept which I have explained right now in this video. That's what we term as dynamic method dispatch. Okay, so many such kind of useful concepts are connected with the inheritance concept here. Likewise, many are yet to come. Now let's go for one more, another concept of connected to the inheritance, that we call as abstract class and methods. Sometimes we'll want to create a superclass that only defines a generalized form that will be shared by all of its subclasses by leaving it to each subclass to fill the details. Such a class determines the nature of methods that the subclass must apply. This can be done by creating a class as abstract. We generally term it as this concept as the interface in actual programming of Java, but interface is very regularly used kind of concept. Abstract classes are rarely used, but let's have focus on this particular concept of abstract class, how to create and use this, and what are the properties of abstract class are, that I'll show. Let's see. So here same program I am just doing here. So math, which contain addition, and arithmetic is extended from the maths, which contain the calculate, which bring the subtraction. Here I am not using the overriding methods. Okay, make sure. And one thing, abstract class, creating object of it, and then logo. Now see what are the property of abstract class are. This is called as abstract class. Abstract class means the class for which object is not possible to create. Object is not possible to create. This we term as the abstract class. And abstract method means the method cannot be called by its object. That is called as the abstract method. This is abstract method without definition is present. If you know the C++, this function we term as the virtual function. Okay, pure virtual function basically, which is equated to 0, and here it's called as the function without any definition. It's called as abstract method. Okay, so it's declared here. Now addition. Now what, when we inherit this class into another class like this, so definition of abstract method is compulsory here. See, overriding the method which is declared as abstract in the abstract class is compulsory. If you don't write this definition here, if you don't write the definition here, I'll put the comment here. Let's look at that. See, so in this particular way it will show the error. See, arithmetic is not abstract class, is not abstract class, and does not override the abstract method calculate. So overriding of method is compulsory. If you write this method here, it should be overridden. So I need to override that. So because we are going to call this method, and how to call that? If you call that this method is not having any definition, then where the definition should present? The definition should present in the class which inherits it. So which has inherited it? This has inherited it. That's why. Okay. So object of this class is not possible to create, but we can create object of the subclass. And now all the properties like var1, var2, var3, I can use it here. And this calculate also I can redeclare by using overriding concepts. Okay, this is what we call an abstract class. So here I call calculate method first. Calculate is calculating addition, subtraction, and addition is finding the addition of these two numbers. So calculate belongs to its own, and addition belongs to the superclass, and based on that we can have the output of this particular statements here. See, addition and subtraction both are printed because the methods are called in that particular sequence. So abstract class whose object is not possible to get created, an abstract method which is not having a definition, but if you inherit that class, abstract method definition should be present inside the subclass which has inherited the abstract class. Okay, these are the properties present there. Basically this property is not used much in Java. We are having the concept of interface, which is just similar as that of abstract class, where we are going to make use of the abstract class concept more effectively by using inheritance and by implementing that particular interfaces also. Okay, we have seen this keyword already, final. We have already seen the use of final to make the constant variable. So when you are going to create the symbolic constants, we are getting the use of the final keyword there. Now it has been associated with inheritance also in two different ways. It is used to prevent the method overriding and the prevent inheritance also. Let's see this. I will not show the practical application, but a snippet of the program will be shown here, and let's talk about this particular concept. So two classes I have declared here, first class and second class is inherited from the first class. Okay, so in this way they are connected. You can just check it out how they are connected together. First class which contain display method, second class contain display method, and it is overridden. Okay, so method is overridden, display method I am overriding from first class to the second class. And what I have added here, you can check this, final. The keyword is final written in front of the method. Now when the method is declared as final, this method cannot be overridden in the subclass. Remember, to see overriding of this method, final methods are not possible. So it will show the error to this particular statement number 1, that final method can't be overridden. So if you want to avoid the overriding of methods, that time we'll be making use of the final keyword in front of the method. Okay, this is the first use of the keyword final here in the inheritance. Now let's see the second use of this. So second use is to avoid the class inheritance. Now let's see, this class is final class first and class second extends first. Now statement 1 I have given here. Remember, what's the meaning of this? If I declare a class as final, this final class can't be overridden, can't be inherited. Inheritance will be disabled when you write the final in front of a class. That is the third application of the final keyword. So final is used in three ways. First way is, that is, create a constant variable. Second way is to avoid overriding of the method, and third way to avoid inheritance of the classes. So last two are connected with the inheritance basically. So most of the classes in Java's API library hierarchy is also having final classes created. These classes we can't inherit, and some methods which are final, these methods we can't override. Okay, that's what meaning of final keyword is. Okay, so one concept I have intentionally added here in this particular presentation, it's called as the object class. What do you mean by object class? Object class, how it's possible? So there is a special class object defined by the Java. All other classes are the subclasses of object. Remember, Java's hierarchy is created in such a way that by default every class that you create, every class that we use from the libraries are direct or indirect subclasses of the class object. Remember, O is capital there, it's the name of the class. It is inbuilt available in Java's APIs. This means that reference variable of type object can refer to any object, an object of any class. Also, since arrays are implemented in classes, object, everything is a part of object there. See this, this hierarchy is already present in the Java classes, already in the APIs of Java Development Kit. This concept is added. Object is a superclass of all, and all other are connected after the object. Okay, see, this is actual hierarchy of Java's APIs for AWT. For creating the GUIs, we are going to make use of such different classes, and everyone is connected in this way. So just like circle, circle is the subclass of conic, conic is subclass of curve, and curve is subclass of object. So whatever classes we have used is like scanner, scanner is a subclass of object, or system is a subclass of object, or any class that we create is also subclass of object, compulsory. Okay, so I'll just show the documentation of from the Oracle's original documentation. Check it out. This is the help shown for object class. It's present inside the package java.lang.object, and it's declared something like this. Class object is a root of the class hierarchy. every class has object as the superclass. All objects including arrays implement the methods of this class. Okay, there is no any class which is independent. I'll just show you here. If it is showing, check it out. See, for example, I want to see the help of a respective class. We just go to the Google and type the name of the classes there and check the documentation of the respective class there. It will show that this class is having object as direct or indirect subclass. Okay, it's not working here, but you can try that. This object class is present as direct or indirect superclass of every class in Java. Advantage is that, see, whatever object method object class contains is applicable to each and every class in Java's hierarchy. Many methods are there, almost 8 to 10 methods that this class is containing. We can apply this method directly to the any class that you create in the Java programming. Okay, that's possible with the help of the object. Now come with the last point of this video, and the inheritance also. It's called a visibility control, and this will form the fifth property of object-oriented programming that we call as the data hiding, data encapsulation. See, in the program that we have seen till, we have not used the concept of data hiding ever. Every variable is accessible anywhere, but remember, if you are comfortable or already knowing C++, you might be knowing public, private and protected. These three keywords are used to hide the data from the external world. So here in Java we have four visibility controls present. This we call as visibility modifiers or the access modifiers: public, private, protected and default. So where are you to apply that? Let's see, I'll just show a simple program here. For example, if I write this variable, these are the variables inside the class. If I write public, then this variable will become public. Okay, what do you mean by public? That I will show. Then second is private. So private is a keyword to define this variable as private. Okay, and third is protected. Protected, third kind of, and fourth is default. If you don't write anything, that is called a default, friendly or the package access. Okay, default, friendly or the package access. Now what's the meaning of this? Okay, so theoretically I am showing it. Practical application we'll see when we see the concept of package. Say first, now consider I am having two packages. Package means collection of classes. That is what we call as package. So in this package I am having three classes, and another package folder I am having where I am having two classes. Now this class, here my class is present. Okay, and variables are present, and any class from the same package is this, and subclass from the same package. Means this class and this class are connected by inheritance, but this class and this class are not connected by inheritance, but they are present into the same package, same folder. Fine. Now another package I am having B here. Now package B contains any class, we are not connected by anything, and subclass means this class A and class B are connected by inheritance, but the thing is that this class is in one package, this class is in another package. Okay, so total four classes I am having: my own class, any class from same package, subclass from same package, any class from another package, and any class subclass from another package. Okay, so in this way these classes are present. Now public visibility control, where the public variables or methods can be accessed. Now when I write anything public here, I can access this public variables in any class of the same package, subclass of the same package, any class from another package, and subclass of another package also. Means public visibility control is having no restrictions. Anywhere public variables can be accessed without any enforcement of data hiding mechanism. This variable can be accessed anywhere. Now second, protected visibility control. If I write protected in front of these variables, we just have shown in the program, protected visibility control. Protected visibility control, this method, these variables we can access in any class of same package, subclass of same package, subclass of another package, plus. Okay, protected members can't be accessed from subclass or any class from other package. See this. This class and this class are not belong to same package, as well as they are not connected by inheritance. In that case, protected members can't be accessed. Okay, either they should belong to same package or they should be connected by inheritance, then only protected member variables can be accessed. Okay, third, default. Default means you don't give any access modifiers over there. That's what we call as the default visibility control. which we call as package access or friendly access also. Okay, now here extra cross is present. Default means package access. If you don't give any specifiers, these variables can be accessed by any class of the same package and subclass of the same package. But if you change the package B's classes can't access anything default from the package A. Okay, not public, not protected, default. Other package can't access it. Its own package is only providing this facility to access these variables. Getting this? Default visibility control. And last, see, till this point we have seen only the default visibility controls. We have not seen private, protected or public, because we haven't changed the packages yet. We are working in the same package. That's why default is working like public. But if you change the package, that time default will not work out of the package. Okay, so we'll see that. And then the last, the private visibility control. Now private visibility control, the private members, so here private members are present in superclass A. They can't be accessed by any other class of same package, subclass of same package, subclass of another package, and any class from other package also. That's what meaning of private is. So private members can be used by its own class and its own methods only. By creating its objects, these private variables can't be accessed outside of it. Okay, so this is what the meaning of private visibility control is. So 4 visibility controls are used to enforce the concept of data encapsulation here in Java programming language. So as per the requirement, we need to use that visibility controls easily in your program. Okay, so all the concepts, this is what the inheritance is, and the core concepts of object oriented programming are. So few more concepts are yet to come that we'll see in upcoming videos. So you just can refer to this book, Core Java Programming, a Practical Approach by me, Tushar Bikute, and all the things, programs which are shown over here, they are presented from the same book. Okay, so in next presentation onwards, we'll continue with the core concepts of programming onwards. Thank you. Thanks a lot.